and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With the spirit of heroism, ITS brings the future before us. ITS, advancing humanity.
Greetings, ladies and gentlemen. Good afternoon from Institut Teknologi 10 November, Surabaya, Indonesia. Welcome to the World Top Scientist Lecture today, Wednesday, December the 1st, 2021. I am Nabila from ITS Global Engagement, and I will be your Master of Ceremony this afternoon. Thank you for joining our lecture today. I do wish that everyone is blessed with health and energy to stay productive. Before we start our agenda, let me inform you some rules for the event. First, please adjust your name or ID screen using Roman alphabet and using name format institution_name. Second, during the lecture, please turn off your microphone and only turn on the microphone when the moderator gives the chance. Third, please fill your attendance through the link shared in the Zoom chat room. Fourth, participants who wish to ask questions during the questions and answer session, please send your question to the link listed in the Zoom chat room as well. Or you can ask directly by clicking the raise hand feature. Today's World Top Scientist lecture will discuss about advanced structural safety studies with extreme conditions and accidents that will be delivered by Professor Jeom-Kee Paik from University College London. This lecture will be moderated by Professor I Ketut Arya Priya Utama from ITS. Also, we would like to inform you that this session will be live streamed on our YouTube channel, ITS International Office. You may subscribe and visit it to check the recording. Ladies and gentlemen, before we start our program, please allow me to greet our honorable guests, Professor Mohammad Asari, Director of ITS Surabaya. Hello, Professor Asari. I hope you are well.
Hello. Good
Thank you
afternoon.
so much. Yeah, good afternoon, Professor. Thank you for spending your valuable time with us today.
Thank you. Thank you very much.
Thank you. And let me greet our speaker today, Professor Jeom-Kee Paik from University College London. Good afternoon, Professor.
Morning, good afternoon, or good evening from all over the world.
Okay, good morning to you. Thank you, Professor. And also our moderator, Professor Iketut Arya Priya Utama from ITS. How are you, Professor?
Thank you. I'm fine. Good afternoon, Nabila. Good afternoon, Pak Rektor Prof. Mohammad Asari. Good evening, Jeom, if you are in Korea, or good morning if you are in London now. Nice to meet you all. Thank you.
Thank you. Thank you for the greeting, Professor. And also join with us today, Dr. Ruli Pratiwi Setiawan, our Senior Manager for World-Class University Affairs of ITS Global Engagement. Hello, Dr. Ruli.
Hello, Nabila. Good afternoon, everyone. Good afternoon, distinguished speakers and also participants. Please enjoy our event today.
Thank you, Dr. Ruli, and thank you all our honorable guests to attending the session today. And also warm greetings to all participants who have joined with us in this beautiful day. Next, allow me to deliver our agenda today as follows. First, the welcoming ceremony and remark from ITS Rector. Second, group photo session. Third, our main agenda, the lecture session about advanced structural safety studies with extreme conditions and accidents by Professor Paik. Fourth, the Q&A session that will be led by Professor Iketut Arya Priya Utama. And finally, the closing ceremony. Now, allow me to invite Professor Mohammad Asari, Director of ITS Surabaya, to deliver the opening remark. Ladies and gentlemen, please welcome Professor Asari.
Terima kasih, Mbak Nabila. Good afternoon, ladies and gentlemen. Good afternoon, good evening, or good morning for our distinguished guest, Professor Jeom-Kee Paik. As mentioned by Pak Ketut Arya, probably you stay in UK or in Korea. So also the Honorable Professor I. Ketut Arya Priya Utama as the moderator today. Good afternoon. Professor Associate Professor Maria Anitya Asari, Director of ITS Global Engagement. Atau Dr. Ruli and all ITS senior, all representative partner university and all distinguished delegates and participants. Thank you, and it is a glorious moment to extend my warm welcome to all distinguished ladies and gentlemen to one of ITS newest programs, namely World's Top Scientist Lecture, the World's Top Scientist Lectures. So through this program, ITS Institute Teknologi 10 November, it means 10 November Institute of Technology. It is a campus in Surabaya, Indonesia, as one of the prominent engineering and science university in Indonesia. It shows that ITS has a commitment to provide a world-class environment in education scope. So on this occasion, also as the opening of the series, we are proud to invite and welcome Professor Jeom-Kee Paik, a prominent professor from Department of Mechanical Engineering, University College London. So he will be sharing insight in advanced structural safety studies with extreme condition and accidents. So I believe that learning from the best is very essential. In addition, I hope that this program would nurture the strong networks among ITS and world-class professors. Knowing the great benefits of his lecture, we are inviting not only ITS students, but also global academicians to this event to grasp the excellence of the lecture by one of the world's top scientists in mechanical engineering. So we are happy now that we have received registrants from more than 15 countries. Of course, it is released in YouTube and also this Zoom media. So I'm certain that this session will be a wonderful platform to learn and could also spark discussion among the speakers and global academicians who are attending this special lecture. So over the next 2 hours, we are going to listen to Professor Paik's talks. It is indeed a privilege, so I suggest absorbing as many ideas as possible and actively participate during the discussion session. So lastly, I would like to thank Professor I. Ketut Arya Priya Utama, who will be the moderator for today's session. And also thank you for ITS Global Engagement Team for organizing this event. So ladies and gentlemen, all distinguished participants, thank you very much and enjoy the session. Selamat sore and again, good evening.
Thank you so much, Professor Asari, for the warm welcome. I bet that everyone is motivated and cannot wait to grasp insight from today's session. Now, before we go to the next agenda, we would like to invite you all for the virtual group photo to capture the moment. So please kindly turn on your camera and share your best smiles. I will start counting to capture the photo. Okay, please turn on your camera. We will start taking the photo. 3, 2, 1. Okay, one more time. 3, 2, 1. Thank you very much. And thank you again, Professor Asari, for spending your valuable time with us. If you have other agenda, please do not hesitate to leave the Zoom room. Thank you so much. Okay, now before we proceed to the discussion, let me introduce our moderator first. Our moderator today is Professor I. Ketut Arya Priya Utama, or also well known as Professor IKAP. He is a professor of ship hydrodynamics in the Department of Naval Architecture at ITS. He is also the head of the Research Center of Marine Earth Science and Technology, Directorate of Research and Community Service, ITS. Professor IKAP also serves as Fellow of the Royal Institution of Naval Architects, or RINA, and he is also the Vice President of RINA Regional Asia. He is also the Fellow of the Indonesian Academy of Science. Professor Ketut also have some awards, including the Distinction Medal Award in 2015 from RINA for the outstanding paper published in 2014, RINA Transactions. He also have the Certificate of Appreciation from RINA in 2015 for continuous work and support for the development of RINA in Indonesia. Okay, as you already know about our moderator, without further ado, I would like to invite Professor I. Ketut Arya Priya Utama to lead the discussion session. To Professor IKAP, the stage is yours.
Thank you, Nabila. Good afternoon, distinguished guests. Thank you very much, Pak Rektor, Professor Mohammad Asari. With your help, then we can invite one of the leading professor in Structure, Professor Jeom-Kee Paik from University College London. Before I let Professor Paik to talk, but by the way, what should I say, Professor Paik? Good evening. Are you in London or in Korea?
I'm from Busan, South Korea now.
Oh, you are in Busan at the moment.
Yes.
Okay. Because usually you mentioned during December until June, you'll be in London.
That's right. Yes.
Okay. But anyway, good evening then. Before you start your very special lecture, let me introduce shortly your CV to the audience. Ladies and gentlemen, Professor Jeom-Kee Paik, our today's speaker, is a professor of marine technology at the Department of Mechanical Engineering, University College London. He is the director of the International Center for Advanced Safety Studies, which has been a Lloyd Register Foundation Research Center of Excellence. He is also an international fellow of the UK Royal Academy of Engineering, and very rare expert actually can be elected at this position, and Professor Paik is one of the very special person. He is also a vice president of the UK Royal Institution of Naval Architects, a founder and editor-in-chief of Ships and Offshore Structures. Professor Paik received several medals, including Dr. Honoris Causa from University of Liège in Belgium, the William Froude Medal from the UK Royal Institution of Naval Architects, and the David Taylor Medal from the US Society of Naval Architects and Marine Engineers. And one of his great achievement actually, he has been authored 8 books, actually 8 very special textbook in structure, over 600 technical articles and over 60 technical patents. Okay, so we believe by this experience, we all know that the reputation of Professor Jeom-Kee Paik. And next, I let Professor Paik to share your experience, your idea, your achievement to the audience. The time is yours, Professor Paik.
Thank you very much. Professor Mohammad Asari of ITS Rector, Professor Ketu Uttama, and all ITS committee members. Congratulations on ITS's 61st anniversary. Thank you very much for having me as a keynote speaker of the event. Let me share my slides. Okay, can you hear me?
Yes, Professor.
Yes.
Okay.
Yes.
Okay. So hello, everyone from all over the world. I hope that all stay safe and strong at this difficult time.
Thank you.
I'm going to talk about the advanced structural safety studies with extreme conditions and accidents. My talks will be composed of 7 parts. Namely, I'm going to define challenges first. And then I'm going to talk about the BUCA environments and the risk-based methods. And then experimental methods by physical testing. And then analytical and numerical methods by computational modeling. I will present some procedures for quantitative risk assessment and management. And I'd like to say something about the perspectives for the future in 2030 and beyond. Finally, we are going to have a Q&A session. Useful textbooks on the topic are available in the literature, but my talks will primarily be based on my own books presented on this slide. Definition of challenges. United Nations strongly suggests to look at the sustainable development goals in association with a total of 17 challenges. As a matter of fact, a number of the grand challenges are relevant. They may be categorized into 10 groups, which are equally important. One of the grand challenges is the issue of energy shortage. Over 15% of population on Earth are living without electricity. With a rapid growth of industrial systems and the products which are operated by electricity, it is expected that the demand of energy will be increasing further in the future. So we have to do something to resolve this issue for energy shortage in terms of meeting sustainability, economy, environmental friendliness, and safety. Next is the issue of water shortage. In many countries, people are drinking polluted waters. Conversion of seawaters into fresh waters could be an effective way to resolve this issue. Another one is the issue of food shortage. 1 of 7 people on Earth is starving every day. Technologies for mass production of foods should be developed to resolve this issue. Another one is the environmental issue in association with global warming and climate change. Zero emission and decarbonization is strongly required to resolve this issue. Another one is the issue of poverty and the difference between rich and the poor. Also, we are very much concerned with the war and the terror. We are now facing a lot of problems in association with the issues of disease and healthcare now. Ongoing Corona-19 pandemic is a typical example for this issue. The issue for democracy, human rights, and inequality is also important. We are also concerned with education. Finally, it is the issue for population. For some countries, birth rates are very low, but for other countries, their birth rates are very high. In overall, the population on Earth is increasing rapidly. It is expected that the population will be over 10 billion by end of this century. All of these individual challenges interact, and they make the issues more volatile, more uncertain, more complex, and more ambiguous. In this situation, what and how are you going to contribute to resolving these challenges? In my case, I have been working for my whole life to contribute to resolving safety issues, which are common to all of the grand challenges. With the civilization, various types of engineering structures have inevitably become available, some of which have been invented rather adventurously. Ships are one of such engineering structures which have been developed for cargo or passenger transportation, leisure, and other special purposes at sea. Sea and the subsea is, as they say, a treasure house of resources for energy and foods. Various types of offshore installations have been developed for energy source production or harvesting, oil or LNG terminals, electric power generation, and other special purposes at sea. Floating types of offshore installations have been used to develop deep or ultra-deep water areas, which are not feasible by fixed-type offshore platforms used in relatively shallow waters. As of 2020, the number of 225 FPSOs are being operated all over the world. Ships and offshore structures are subjected to various ocean environmental conditions in operation, which include, of course, waves and the wind. They should, of course, be able to sustain such environmental conditions. For safety engineering of ships and offshore structures, ocean environmental conditions should be quantified with accuracy and certainty. While in service, ships and offshore structures are necessarily subjected to normal conditions, but they are likely subjected to various types of abnormal conditions. From the beginning of construction, ships and offshore structures are subjected to extremely high temperatures of over 1000 degrees Celsius, owing to welding and the flame cutting, which result in initial imperfections in the form of initial deformations and residual stresses. And then freak and the rogue waves or wind give rise to abnormal loads. Dynamic pressure loads are arising from sloshing, slamming, or green water. In active operation, ships and offshore structures are subjected to sub-zero temperatures. Cryogenic conditions are owing to LNG or liquefied hydrogen cargo. They may also arise from accidental leakage of LNG fuels. In this case, steel structures can exhibit brittle fracture, which gives rise to a catastrophe. Subsea structures in deep and ultra deep waters are subjected to ultra high pressure loads. Fire accidents can happen in engineering structures, causing elevated temperatures and resulting structural failures. Explosions bring blast pressure loads, causing structural crashlessness involving crushing and fracture. Impact loads are arising from collisions, grounding, or dropped objects. As ships and offshore structures are getting older, they suffer from in-service damage, such as corrosion wastage, fatigue cracking, or local denting. Extreme hull girder loads can break hull girder into two pieces. The sources of such individual events are different from each other, but their consequences are common in terms of structural damage and failures, which are highly complicated to solve, owing to highly nonlinear structural mechanics, non-Gaussian characteristics, multiple physical processes, multiple scales, and multiple criteria. Obvious trends are relevant on design, building, and operation of ships and offshore structures in terms of environmental friendliness, economy, and safety. To achieve environmental friendliness, zero emission and the decarbonization should be applied for shipping. Alternative fuels such as LNG, ammonia, or hydrogen gas have already been considered to propel ships. Here is a 3-minute clip for such perspective from the UK Royal Institution of Naval Architects.
The Royal Institution of Naval Architects was established in 1860, which is actually 9 years before this beautiful vessel was built. It was state-of-the-art and innovative at its time. So RENA has evolved with the times over its 160 years to be at the forefront of innovation, disruptors and enablers. Whether it's the design, construction, operation or maintenance of marine vessels, that's what we do. I'm extremely proud myself to be a naval architect, and I consider ourselves total engineers. The Royal Institution is the governing body for technical excellence and prowess within naval architecture and maritime engineering. It's not just a British-centric organisation. We are represented globally in 96 countries. So what we are is the knowledge centre, and the knowledge centre for ideas. RENA is at the forefront of learning and education. We accredit universities, colleges, businesses. We look at the continual professional development of all our members and all our engineers. RENA has to evolve and evolve with the time. We look at the digital revolution that's happening and all the threat actors that we currently face. Cybersecurity is something we take extremely seriously. We lead from the front. We don't just talk about this. Sustainability within RENA is the big question. Decarbonization, net zero, the impact for the ship owners, the impact on design, research and technology. Wind propulsion is a major area of focus for the Royal Institution. All the thought leadership is fed through into the peak bodies such as the IMO, whereby we can influence and debate regulation and policy to make the difference.
The IMO is an agency of the United Nations. We work together with 174 member states to find consensus on issues like safety and environmental protection. RENA has had a long history of working on improving safety. It is a hugely exciting time. We're in the time of great change and transition. The role of RENA is very, very important. We are doing everything we can to design more efficient ships, to adapt ships to use different types of fuels.
It's really important that RENA drives the education that's required so that we get the right people with the right skills into the maritime industry. When you're training to be a naval architect, it's really beneficial to be part of an organisation like RENA. And this is because there's an opportunity to exchange knowledge, learn from people who've been in the industry for a long time, and also source information and academic papers. In addition to this, it's not just open to naval architects, it's also open to the wider maritime industry. RENA gives you lots of opportunities.
The Royal Institution is changing. We are currently going through our digital transformation. We are modernising the way we look and communicate with members. Get involved with the Royal Institution. Actively get involved with debate, research, knowledge and change. So this is my call to arms as Chief Executive. Please come and join the Royal Institution of Naval Architects.
In recent years, the size of ships has become very larger. This is because the international shipping industry desires to economize by lowering operating expenditures as well as building costs. And therefore, ship sizes have increased substantially, and with them, the capacity to carry more cargo for the same or lower costs. Despite the significant efforts, maritime accidents continue to occur, affecting casualties, property damages, and marine pollution. Therefore, it is very important to minimize the risks of accidents at every stage of design, construction, operation, and decommissioning. BUCA environments and risk-based methods. Traditional allowable stress-based methods are no longer adequate to apply, and therefore, limit stage-based criteria must be used for structural design and safety assessment. Structural systems or their components reach limit states if they fail to perform their functionalities. 4 types of limit states are relevant, namely ultimate limit states, serviceability limit states, fatigue limit states, and accidental limit states. Ultimate limit states are caused by buckling and plasticity under extreme conditions. Serviceability limit states are associated with the noise and the vibration. Fatigue limit states are due to initiation, growth of cracking damage under repeated loading. Accidental limit states are associated with the structural crashworthiness and the survivability in accidents. 4 types of structural safety study methods are relevant, namely partial safety factor-based method, reliability-based method, failure probability-based method, and the risk-based method. Currently, shipbuilding and offshore construction industries primarily use the partial safety factor-based methods for structural designs. However, accidents are the result of BUCA environmental and operational conditions in terms of volatility, uncertainty, complexity, and ambiguity. It is now well recognized that the risk-based methods are the best way to effectively manage BUCA environments and ultimately resolve such challenges. Paradigm shift is now relevant for safety design engineering of ships and offshore structures under extreme conditions and accidents. Not only functional requirements, but also health, safety, the environment, and ergonomics, or HSE and the E requirements should be applied. The functional requirements present the operability in normal conditions, but the HSE and the E requirements address the safe performance and the integrity in extreme and accidental conditions. The former can use the prescriptive approach with the linear algorithms, but the latter should use the probabilistic approach with the non-linear algorithms. In engineering community, risk is defined as a product of F and C. F is the frequency of hazards, and the C is the consequence or severity of hazards, which is characterized by limit states and the structural crashworthiness analysis. The task of risk assessment is to calculate the risk R. To be safe, risk R should be smaller than the acceptable level in association with RLAP, or as low as reasonably practicable. Otherwise, risk management is required to reduce F or C or both. Where risk mitigation options are applied from the cost versus benefit analysis. An extreme or accidental event in a structural system is always associated with multiple parameters, which are always random and probabilistic by nature. Therefore, a huge number of possible scenarios must be considered for the real events. For advanced structural safety studies that involve refined computations and the physical model testing, it is essential to select a set of realistic scenarios which should represent all the possible events, but with a limited number, which is needed to minimize the computational costs. Experimental methods by physical testing. For the limit states and the structural crashworthiness analysis, in extreme conditions and the accidents, computations alone are not always sufficient enough. Because they are highly nonlinear with a lot of uncertainties and the multiple physical criteria involved. Therefore, multidisciplinary approach is essential together with the testing, monitoring, and the training. Specifically, testing with a full-scale prototype or at least large-scale models is highly recommended. Small-scale models or toy models may distort the real physics because scaling laws are unavailable to convert from small models to full-scale prototypes under extreme and accidental conditions. COSORI, the Korea Ship and Offshore Research Institute, which has been a Lloyd's Register Foundation, Research Center of Excellence since 2008, built a world-class test site in Hadong, South Korea. Here is a 1-minute clip showing the test site. Test facilities in extreme conditions and accidents such as buckling collapse, dropped objects, collisions, grounding, fires, and explosions are available altogether at the test site. Also, subsea hyperbolic pressure test facility is available in which over 800 bar pressure loads equivalent to water pressure of 8,000 meters water depth can be applied in a hyperbolic cylinder with a diameter of 1.8 meters and a depth of 4 meters. Here are some selective physical testers. Has been conducted using the test facility. This figure shows a structural failure testing. Okay, so this figure shows the structural failure testing collision between iceberg and the ship. Both iceberg and the steel plate panels are considered as deformable structural failure. This physical testing was conducted to investigate how impact energy is consumed by damaging both struck plate panels and striking iceberg. The test results were used to validate computational modeling techniques for the structural crashworthiness analysis in collision between steel-plated structures and the iceberg. LNG-fueled ships can accidentally leak LNG fuels to steel structures. In this case, steel structures are subjected to cryogenic conditions of extremely low temperatures, which can cause brittle fracture and compressible loading. This physical testing was conducted on full-scale ship-plated structures and actual compressible loading at a scenario of liquefied gas leaks. Liquefied nitrogen gas was used in the testing instead of LNG because of safety issue, but the target temperature was achievable at -160 degrees Celsius. Sometime after gas leak, the leaked gases had been evaporated, and subsequently, the gas cloud temperatures have increased. When the temperature reached -160 degrees Celsius, actual compressive loading was applied by using 2,000-ton loading actuator. As you can see from the testing, steel structures reached ultimate limited states triggered by brittle fracture. On the other hand, at the room temperature of 20 degrees Celsius, the same structure reaches ultimate limit states by usual tripping of stiffness under axial compressive loading. These tests obviously tell that the brittle fracture can be a critical failure mode for steel structures at cryogenic conditions. Fire or explosion tests are conducted to quantify the profiles of fire loss or explosion loss. This figure shows a 1/2 scale test frame of separation topside modules for BLCC class FPSOs at the Kosori test site in South Korea.
Repeating our explosion, this time with
This
the water
figure
spray.
shows
So let's see what the
explosion,
blast did to our
test,
dummy equipment.
carried out
And the
at
dummy
different
equipment
test
is
sites.
left standing. The research is showing that simple measures can make a 3/4 of a ton of metal, not for 6.
In order to mitigate the blast pressure loss owing to explosions, water spray is usually applied as a safety measure. The left-hand side test did not apply the water spray, and the right-hand side test applied the water spray. But by comparing these two tests, you can see that the yellow bar structures outside the test frame in explosion did not survive on the left-hand side testing without the water spray safety measure, but they survived on the right-hand side testing with the water spray safety measure. This is because the water spray application was decreasing the blast pressure loss significantly owing to explosions.
3/4 of a ton.
Analytical and numerical methods by computational modeling. Within the framework of quantitative risk assessment and management associated with extreme conditions and accidents, the limited states and the structural crashworthiness analysis should be undertaken. The term structural crashworthiness is generally used to describe the performance of a structure impacted by another object or blast pressure loss involving crushing and fracture. The aims of structural crashworthiness analysis are to identify resultant forces and the energy absorption characteristics, as well as structural damage and the survivability. A number of factors and the mechanisms affect the structural crashworthiness, namely buckling, plasticity, crushing, fracture, initial imperfections, age-related degradation, loading speed, temperatures, friction, surrounding water, and the interaction between involving bodies. Such factors should then be formulated efficiently and accurately. In order to solve engineering problems, mathematical models should be formulated. Engineering modeling is a task of idealizations at an acceptable level of the accuracy needed and the degree of the complexity of the analysis to be used. Generally, a more sophisticated model produces a great degree of accuracy. Here is a simple example to illustrate the concept of engineering modeling. Just consider the calculation of this land area with an irregular shape. How can you calculate the land area within limited time and cost? Think about it. For engineering purpose, you may simplify the shape of the land area as circle or rectangle or triangle, so that the land area can be predicted easily by existing simple formulas. You can call them as the circular model or rectangular model or triangular model. Most of the main engineering works are to develop such models, which should be as possible as simple and also accurate. For steel-plated structures, which are the basic structural components of ships and offshore structures, they are often modeled by assembly of plate stiffener combination models or plate stiffener separation models or finite elements. Boundary conditions of structural members can be modeled in between precondition to fixed condition, depending on the degree of rotational restraints. Analytical methods are basically aiming at solving governing differential equations under loading and the boundary conditions. They are very useful because accurate solutions are provided as far as governing differential equations are formulated and they can be solved. However, it is very difficult to apply analytical methods for the limited states and the structural crashlessness analysis in extreme and accidental conditions. Computational methods are then required to apply instead. Structural scantlings of ships and offshore installations are primarily determined by ultimate limit state criteria. Other types of limit states are considered as a supplementary after the ultimate limit states-based design is completed. Ultimate limit state-based design optimization procedure is used for structural design and multiple objectives such as weight minimization and safety maximization. In computational modeling for the limited states and the structural crashlessness analysis, it is important to understand that the material properties in impact loading are totally different from those in static or quasi-static loading. The material's yield strength tends to increase with the increase in the loading speed. This behavior is dealt with in a parameter of strain rates. The increasing trend of the material yield stress for high tensile steel is more moderate than for ordinary steel. On the other hand, the material's fracture strain tends to decrease with the increase in the loading speed or strain rate. This means that the structures struck by impact loading are vulnerable to fracture. Ships and offshore structures are also exposed to sub-zero temperatures in active operation or cryogenic condition owing to unwanted leaks of LNG or hydrogen gas. Brittle fracture may happen if the exposed temperature is lower than a critical temperature. Brittle fracture may also happen even at sub-zero temperature if loading speed is very high. Relevant material models should be used to take into account the effect of sub-zero temperatures. Ships and offshore structures may also be exposed to elevated temperatures in fires. The material's elastic modulus and yield strength decrease significantly with the increase in the temperature. Relevant material models should be used to take into account the effect of elevated temperatures for fire safety engineering in association with the progressive structural collapse in fires. From now on, procedures of quantitative risk assessment and management are addressed for some selective events of accidents. There are hazards that ships and the ship-shaped offshore installations break their hull owing to aging-related deterioration or accident-induced damage or accidental flooding, together with the extreme hull girder loading conditions. Computational models for the progressive hull girder collapse analysis under such conditions should be developed. There are hazards of collisions built in ships or built in ship-shaped offshore installations and the shuttle tankers or supply vessels. Various parameters affect collisions, including size of striking and struck ships, speed of striking and struck ships, shape of striking ship bow, location, angle of collisions, etc. Both frequency and consequence are computed to calculate collision risk, where a number of realistic collision scenarios are selected in a probabilistic manner. Structural crashworthiness analysis in collisions involving crushing and fracture is conducted by nonlinear finite element methods. Grounding risk is associated with the bottom damage of ships when a ship runs on a rock with a forward speed. Again, various parameters affect the ship grounding, including size of grounded ship, forward speed, trim angle, geometry and shape of rock, etc. Braking damage can be formed in grounding, resulting in capsizing or spills of hazardous cargo. Fire safety engineering studies how fires start, spread, and grow, causing structural damage and collapse. Hydrocarbon fire in engineering structures is a combustible vapor or gas that combines with an oxidizer, usually oxygen or air, in combustion process that manifests in the evolution of light, heat, and the flame. Various parameters affect the fires, including gas leak rate, gas leak duration, gas leak direction, gas leak location, wind direction, and wind speed. In order to characterize fire laws, CFD or computational fluid dynamics simulations are required. Gas cloud temperatures are transferred to steel structures. Nonlinear finite element methods are used to simulate structural failures in fires. Explosions are often accompanied by fires, but their underlying mechanisms are completely different from each other. Released hydrocarbons, such as oil or gas, that combine with an oxidized, usually oxygen or air, together with the ignition source, cause fires when the concentration ratio of the gas cloud is thick. However, explosion occurs when the gas concentration ratio becomes thin. In contrast to fires, hydrocarbon explosions result in a blast or rapid increase in overpressure, which can cause the catastrophic failure of structures. Parameters affecting explosions additionally include the gas volume, gas cloud locations, and the gas cloud size. Ship floor earthquakes are of a safety concern for both fixed and floating offshore installations because they may lead to hazards associated with the damage to sensitive equipment, such as damaged nuclear reactors in a ship-shaped nuclear power plant, or a fire initiated by broken gas lines, risers, and/or power lines. Ship-shaped offshore installations must be designed so that their safety be secured even under seismic loading due to earthquakes. Actually, elastic waves of excitation are generated in soils, and the resulting energy is radiated in earthquakes. The responses of hull structures and the soils to such energy are governed by ship motions, such as sway and heave motions, together with the surrounding water effects. Computational models should be developed for seismic impact engineering of offshore installations. Ship-shaped nuclear power plants may be subjected to aircraft impacts owing to terrorist attacks or accidents. Even in such a hazardous scenario, the catastrophic consequences must be prevented or minimized. An applied example is shown here, in which an aircraft of Boeing 777 aeroplane strikes the side structure of a ship-shaped nuclear power plant at a full speed of 200 meters per second. The double side space of the hull structure has been strengthened by concrete. Of main concerns is to confirm if the silo and the nuclear reactor zone is safe enough at this terrorist attack. Perspectives for the future in 2030 and beyond. Evolution of the communication technology has happened at every 10 years. In 1980s, the first generation 1G was bringing with the portable phones, which were so heavy though at that time. In 1990s, 2G was making possible to communicate by emails. In 2000s, 3G made possible to communicate by mobile internet. In 2010s, 4G was able to deal with the movies and games online. In 2020s, we are now here. 5G appeared to make possible for virtual meeting happening today. And we expect 6G to appear in 2030, so that the ultra high speed access on real time without any delay of transition will be feasible. By the evolution of communication technologies, together with the information technologies, we forecast with a reasonable certainty that our world in 2030 and beyond will have a very advanced industrial products with the metaverse, remote monitoring and management, and unmanned systems by taking advantage of 6G, XR, Internet of Things, and AI. One of the safety study areas by taking advantage of such technologies is by digital twin systems for lifetime healthcare of engineering structures. The importance of lifetime healthcare is emphasized not only for human bodies, but also for engineering structures, because both of them must receive regular and proper care through ongoing health monitoring, periodic condition assessments, and the predictions of likely future health conditions. Human bodies are regularly subjected to medical examinations for health monitoring, both before and after birth. Visual examinations are performed by medical professionals, and advanced imaging devices such as ultrasonography and magnetic resonance imaging are used to observe the internal anatomy and the symptoms of illness and disease. Such health monitoring is used to determine physical and mental well-being and whether physical, medical, or surgical treatments are required. Modern technologies also enable future health conditions, such as disease, to be predicted from analysis of a patient's genome. Consequently, in some cases, certain medical treatments can be used to proactively prevent the development of disease. For engineering structures, on the other hand, similar processes are applied from design to building, operation, and decommissioning. At design stage, they are ensured to comply with the intended functions. Health monitoring is conducted to detect in-service damage and age-related degradation through close-up inspections assisted by advanced equipment. Health conditions are assessed to quantify reductions in structural safety and integrity due to such damage and deterioration, and thereby determine whether repair or renewal procedures are required. Likely future damage, such as corrosion wastage, is predicted and appropriate proactive safety measures are taken. By the help of such advanced information and communication technologies, digital twin systems can be developed for lifetime healthcare of aging ships and offshore structures, which may suffer from in-service damage such as corrosion wastage, critical cracking, and local denting. This figure shows a system of the digital twin for lifetime healthcare of aging offshore installations. So thank you very much for your attention. I will be pleased to reply to your questions you may have.
Okay, thank you very much for your very interesting lecture, Professor Paik. And now, session for question and answer. Okay, I let every participant to ask. Okay, you can send your question through the link given by the committee, or you can say directly. You can raise your hand.
Yeah, please raise up your hand if you have any questions. Actually, otherwise you can send me emails at any time with my email address here.
Okay, while waiting questions from audience, Professor Paik, let me ask you. During your lecture, you mentioned there's a case of fire, okay, on the vessel. What should we do? What should we check actually after the accident? Can we still use the vessel after several improvement, or just say demolish the vessel? Could you give maybe some example we could learn from that? Thank you.
Okay, so well, actually, as I mentioned earlier, the fires may accompanied by explosions in industry. So let me explain about these two phenomena, two types of accidents. Well, basically, fires or explosions are taking place. Two, the parameters. One is the flammable gas or oil. So there should be a the leaked gas or oil, and then together with there must be ignition source. Ignition sources are usually coming from the sparks of the generators or something like that. So the leaked gas or oil are ignited. Then fires or the explosions are taking place. Then now we have to do something for safety engineering, namely the active safety measures and the passive safety measures. The aim of active safety measures is to prevent the accidents that themselves proactively. So these measures will be aiming at preventing accidents itself. Passive safety measures are going to minimize the structural impacts or severities due to accidents. Well, actually, in terms of the casualties, the property damages, and marine pollutions. So proactive or active safety measures, include, for example, usually gas leak is happening through the damaged the pipelines or valves. Therefore, these bulbous pipelines, aging pipelines should be monitored regularly, and then it should be repaired if needed. Therefore, gas leak should be prevented, should be avoided proactively. So this kind of actions are active safety measures. And then now, in terms of passive safety measures, for example, fires will cause very high temperature. Gas cloud temperature in fires will reach over 1,000 degrees Celsius. So all human bodies will be damaged, will die. So it is extremely dangerous. Then these gas cloud temperatures will be transferred into steel structures so that the structural failures or progressive collapse will happen subsequently. Therefore, you may consider the passive safety measures like firewalls. So looking at the top side modules of the offshore installations, you should divide the working place and the accommodation, for example, or the place where the crew members are working. Then the firewalls can divide and to remove to minimize or to remove any unwanted temperatures from fires. Same is true for explosions, for example. Explosion, the blast walls, kind of walls, blast walls should be formed, should be added, should be considered to prevent the high impact blast pressure loss arising from explosions. So let me tell you and also in terms of design, the fire or explosion safety engineering is extremely important, because all of these accidents will be closely associated with structural damages or failures. But these are the main contents of my lecture today.
Okay, thank you. The fire problem explosion, Prof, quite a lot in the case of Indonesia, especially with car carriers. For example, during the trip, the car, like the bus, still turned on by the driver. And this one actually caused the possible ignition.
Yeah.
Okay. Thank you. Yes,
yeah. To your comment. Well, actually, in as far as the ignition is not applied, the fires or explosions may not happen. At least, for example, right? So of course, some gas leaks will be hazardous in terms of the toxic material is included in gas. So that will be another issue. But basically, for fires or explosions, both the flammable material like oil or gas and ignition will cause fires or explosions. So if you are, of course, you are encouraged, you are recommended to prevent for both the leak of gas, unwanted leak of gas, together with the ignition sources. But at least one of them can be managed. Such accidents will not happen. I see that one of audience, Cindy, Aziz.
Yes,
Cindy
Aziz Cindy from UCL. Please, Aziz.
He's my student.
Oh, your student. Yeah. So your face, please.
Aziz.
Aziz.
Yes, first off, I'd like to say, Professor Jeom, that was a wonderful lecture and very informative, even for me doing research in the subject. I have one question at the start. You've mentioned about sustainability and production, and in specific with food production and energy. You said that mass production could be a solution to sustainability and, for example, feeding the people that are in need of food. But would you say that more localized production could also be a solution for energy and for food, for sustainability reasons and for as well as poverty?
Yeah, indeed.
And I do have. Go on.
Yeah, indeed. Well, I mentioned basically massive production of the foods or the energy is important in an overall sense. Looking at, for example, food shortage issue, not only global but also local production is important, of course. But basically, for scientists and engineers like us, we have to develop some advanced technologies to produce the foods massively, in a massive amount. So, for example, the seafood, for example, we are now able to farm instead of simply catch the the fishes. So the fish farming is one of the way to help resolve this issue. And also in the past, some I'll say things have to be farmed in good soil, but even now we are now developing technologies to produce foods on desert, without water and nothing is there. So basically, we are expecting the population, which will be over 10 billion by end of this century. We need obviously need to develop to resolve the issue associated with the food shortage. In terms of the energy shortage, again, similar ideas can be said, can be applied. So as they say, the energy sources on land, have been decreasing. Then that's why we are now going to sea and the deep sea to develop oil or gas. Then, as I mentioned, the sea, but the subsea is a treasure house of energy sources, not only for hydrocarbons but also minerals, and also sea is the treasure house of foods, as I mentioned. So again, there are a lot of the grand challenges that we scientists and engineers should do something to help resolve these grand challenges. Thank you.
Thank you. I have one more question as well.
Oh yes, please. Yes, come
on. In terms of accidents and avoiding them, do you think it's realistic to say that something like automation, upcoming technologies, would be a solution for big-time accidents that are happening in the marine industry?
Yes, sure. I think so. That's because as they say, from the statistics of accidents, there is obvious I would say evidence that the over 80% or even 90% of accidents are caused by human errors. So in many ways, in terms of design, operation, whatever, at every stage of design, construction, and operation, human errors are causing accidents. Therefore, how the human errors are taking place? That's because the human bodies, we are making some mistakes. Therefore, if we are able to make automation, then we will be obviously to reduce such human mistakes or human errors. Therefore, automation is very useful to prevent accidents. In the future, for example, when automation has been measured, then you may say now machine errors. So then, I believe that the machine errors will be much less severe than the human errors. That's why we are now we are trying to develop the autonomous systems, unmanned systems for cars, but even the ships, to prevent unwanted collision accidents. Thank you.
Thank you.
Okay, thank you, Ajis. There's another question actually from the link, Prof. Paik. Let me say that from Rizky Chandra Ariesta from ITS, with the development of existing structural science, is it possible to make observations of structures in real time? And if yes, how to correlate structural progress with decarbonization issues? Okay, please, Professor Paik.
Will you explain more easily?
Okay, one by one, sorry. Okay, first, with the development of existing structural science, okay, in the development structure study,
Yes.
Is it possible to make observations of structure in real time?
Okay. So, this is related to my actually suggestion of research for lifetime healthcare of aging structures. At the moment, it is quite difficult to to monitor any events or accidents on real time. We are now working very hard, but actually two things. For health condition monitoring, you may take advantage of sensors which will be built in on your target structures or infrastructure, and then these sensors will measure or monitor or measure the any physical data like deformation or the strains. And then this data will be transferred to your office, for example, your computer on land. Such things. And of course, in this case, you may also monitor any symptoms of the accidents, like, for example, the gas leak. You may detect the gas leak earlier, much earlier, so that you can avoid or prevent subsequent accidents like fires or explosions. This kind of things in the middle of developments now, and as I mentioned, my suggestion is that we have to work very hard and faster.
Okay, thank you. And the second question, how to correlate structural progress with the current issue about decarbonization?
Well, actually, our target in maritime community is to looking at some 2050. By 2050, we we are, there is a very ambitious plan, but we are aiming at making to achieving zero emission. So 100% decarbonization by 2050. So how can you do this? There are a lot of the not just one way to achieve these goals, but there are multiple the methods which should be applied simultaneously. One is the the fuels, alternative fuels, like so definitely the ammonia or the hydrogen gas. Currently, we are using the LNG, gas for fuel. Then again, these LNG fuels are not perfect in terms of the emission. So eventually, we are now looking at the ammonia or hydrogen gas as alternative fuels. This will greatly help. And another point is that looking at the overall picture of the emission, the maritime industry or shipping industry is contributing to some less than 5%. The largest contribution, the biggest contribution is from the energy plants on land, and some the car automobile industries or something like that. So the maritime industry is contributing to produce emission by some 5%, or as they say, 3.3% or something like that. This is small amount of emission, but still we are, our ships are operating all over the world, all over the globe. So this will impact on emission. So our maritime community should work to make the zero emission or decarbonization, so that the global warming issue and global climate change should be resolved.
Yes, I agree with you in terms of CO2 emission. Okay, but if say VLCC like Exxon Valdez broken down and then release huge amount of oil and then contaminated the environment, maybe we have to consider about that actually, Prof. Paik. Okay, thank you. Is there any questions? Please, the participant.
Yeah, Mujib.
Oh, yes, Mujib Ahmed. Please
good evening, sir.
introduce yourself quickly and then raise your question.
Good evening, Professor. I'm Mujib. So I am a research associate, University of Strathclyde. So I did PhD under Professor Paik. So first of all, thank you for a very good presentation. So just a small question regarding digital twin, like how effective is this in controlling or assessing the health condition of the ship? Do we have a real demonstration of this application to any of the ship available?
Yeah, so yeah, actually, Mujib is a former student of mine under my supervision. He got a PhD degree a couple of years ago. Well, so thanks for your questions. And well, digital twins for lifetime healthcare of aging ships and offshore structures. Well, actually, as I mentioned earlier, the first challenge to achieve the digital twin systems for lifetime healthcare is to how to actually deal with the real time the monitoring and the measurement by sensors. this one challenges. Of course, we have some good, the sensors and the related equipment, but it is challenging and how to monitor and measure or detect the in-service damages by sensors. I think the transition or transfer of monitored data to compute digital twin on which must be located on land of your office is relatively easy to apply. And then again, you need to simulate the structural responses of your and obtain or measure the data in terms of the laws, applied laws like wave laws, wind laws, whatever, and then structural responses in terms of the limited states and if needed, the structural crash resilience analysis. So this will be conducted. Then you can assess the health conditions of your structures. Then you can make some judgment whether or not your structures are healthy. Otherwise, you have to consider some remedial actions such as repairs or even renewals. Repairs is a small amount of the medication for health, human bodies, for example. But renewal works will be largely surgeries. Okay, so it will take a lot of time and money. So your structures should stop operation. So downtime costs will be increasing significantly. So this kind of process should be integrated altogether. And again, as far as 6G communication technology becomes available, there will be no delay of real-time monitoring. Therefore, you can make health condition monitoring and condition assessment on real time without delay of any time on your office. Most of all, we are expecting to see the 3D metaverse like a hologram systems. Right? So not only just in your computer, but you can see the holograms, 3D holograms in the future, for example, probably 2030 or 2040. So I believe this is my belief that this will definitely appear in the future. So we have to work hard. So this kind of efforts will contribute to resolving the grand challenge as mentioned earlier, because these kind of things, efforts will reduce definitely reduce the casualties, property damages, or environmental pollutions. Thank you.
Okay, thank you, Prof. Paik. There's another question from Mr. Juan Miguel Macalintal. He is from the La Salle University in the Philippines. His questions: how critical are cabin configurations or layout in the analysis of primary structures for the ship? Or is cabin modularity usually covered by worst case analysis? Okay, please, Prof. Paik.
At the design, preliminary design stage, how can we deal with the safety? Well, basically, structural design process is something like this. We have to define the laws, I say design laws, For ships and offshore structures, that will be wave laws or wind laws or current laws or something like that. So environmental laws together with operational laws. So laws should be defined, but that will be changing. I would say volatile, changing with the time and in size, I would say in size actually. So you have to define so-called the design values of applied laws. This is first task. And so in this case, you may consider normal conditions, normal conditions, together with abnormal conditions. As I mentioned, abnormal conditions are associated with extreme conditions or accidents. So usually structural scantlings at preliminary design stage is undertaken based on normal operations, normal conditions. And then extreme conditions and the accidents are considered later on, but definitely this is associated with safety engineering. And the structural scantlings will be determined by the strength analysis together with the design laws that have been defined. So my point is that even at the preliminary design stage, you have to consider not only normal conditions, but also abnormal conditions of extreme and accidents. Fortunately, there are the good textbooks already in the literature, so you may refer to such textbooks. Okay, any other
questions? Thank you, Prof. Paik. Sorry, hard rain in my house, then sorry, maybe disturbing place. Any other questions, please? I see like Dr. Yuda Hermawan. It looks that you would like to ask something, please.
Yes, Prof. Ketut. Thank you for the times. Hello, Professor Jeom-Kee Paik. I am Yuda from Department of Naval Architecture, the same department with Professor Ketut Priya Utama. I have one question, Professor Jeom-Kee Paik. Actually, as I know, one of the important thing for the offshore structure, especially for ship offshore structure, is the motion to the couple motion to the mooring lines, Professor. So as we know, actually, and so as I know, actually many research concerning to the how to calculate the couple motion and also the effect of mooring structure to the ship's offshore structure, including uncoupled motion and also coupled motion, Professor. But as I know, limited research related to the tension motion to tune the mooring line while the mooring line broken, Professor. So how do you think about the condition, especially for the safety of offshore structure? Because as we know, when we analyze the mooring analysis or the structure of the offshore structure, the classification society requires the two conditions. First one is the operation or intake condition, and second one is also the limits of mooring lines condition. Sometimes when we calculate or when we analyze, sometimes a tension motion to tune the broken of the mooring lines happen. What do you think about that condition of Professor?
Okay, thank you for your question. Yeah, well, basically, mooring line design and engineering must be based on the site-specific methodology data. So usually the spread mooring lines are considered for benign conditions without storm conditions like West Africa, Angola area, for example. So in this case, you don't have to consider any thread mooring type system, but basically you may use the spread mooring. In this case, you can consider that the mooring lines may be broken in some cases. So basically, you will be able to analyze the vessel motions at the site-specific metocean data, so that you can define the so-called design laws which are applied to mooring lines. So, of course, basically mooring lines will be broken if the tensile laws are increasing, exceeding the critical values. So, so in such cases, you may add the number of the mooring lines, so that each of individual mooring lines will sustain less loss of application, right? Or you can design the stronger mooring lines or something like that. So this is one thing, but at other places where the harsh environmental conditions, you may not consider spread mooring lines. In this case, you will consider the single point mooring or thread mooring. So this single point mooring system or thread mooring system will be weather vane. That will be rotating so that the wind or wave loss will be minimized, something like this. Even in other cases, such thread mooring or single point moorings will be disconnected at storm conditions, so that the FPSO will be moving to shape region and then come back after storm is gone or something like that. Thank you.
Okay,
So,
thank you very much.
Well, regarding your question about coupling or decoupling of the applied load components, can be taken into account in your CFD simulations. Thank you.
Okay, thank you, Prof. Paik. The end of session is coming soon. Perhaps there's one more questions maybe before we close the session. Anybody would like to ask Prof. Jeom-Kee Paik? Yes, who's it? Chandra again? Okay, please, Rizky Chandra, you can ask him directly.
Okay, I'm sorry, Prof. I asked an hesitant question. Okay, before my name is Chandra and from Department of Naval Architecture, same with Prof. Iketut. Yeah. Okay, Prof. Jeom, thanks for your materials for today. It's so impressive. I mean, like, I have a question about numerical analysis, especially in the finite element methods. This is maybe it's basic question, but I want to know how your perspective about when we define a numerical analysis to approach experimental condition. Is it there is always special treatment with uncertainty parameters given to justify, or we can decide from the several experiment approach? What do you think about that, Professor Jeom? Thanks for this opportunity, Prof.
So your question is about the definition of the best finite element size for
Yes,
analysis,
especially about
for limited state and structural crash resistance analysis, right?
Yep.
Two things, let me tell you. One thing is you will do so-called convergence study. Convergence study is to look at how the structural responses will be varying with the different mesh sizes. So x-axis, we will draw a the figure. The horizontal axis will be representing the size of meshes, and the vertical axis will represent the structural responses in terms of, for example, deformations or something like that. So you will investigate how deformations will be changing with the varying mesh sizes or number of finite elements. So that deformation must be approaching the specific value. So you can define, you can catch the so-called best size of finite elements. So usually you have to perform at least some 5 cases for the convergence studies, meaning that you still have to do to take times, right? To take efforts, right? If you don't like to do this, I suggested some simple procedure to define the best size of finite elements. You can refer to my textbooks, but basically let me tell you simply, the structural crash resistance always involves crushing or folding. Fracture is another issue, but usually thin-welded structures like ship structures or ship-shaped offshore structures are exhibiting the folding or crushing in excessively large applied loads, right? So crushing will happen. Then this is very, very non-linear mechanisms, So looking at the crushing or folding mechanism, you have to have at least 8 finite elements for one crushing length. I would say half of crushing length. For thin welded structures, you are able to define the crushing length. There are several analytical solutions. For example, Professor Jeom-Kee of MIT, his team has been deriving some good formulations to to predict the crushing length, for example, meaning that you are able to calculate the length of crushing length by analytical solution. Then for this crushing length, you will assign at least 8 finite elements. So that will be giving very good accuracy. So meaning that you don't have to do convergence study by taking a lot of times and the computational costs. But you are recommended to do convergence study.
Okay, thanks, Prof.
Okay. Thank you. Yeah.
Thanks.
So again, thank you very much for the answer, Professor Paik. Unfortunately, the time progressed and now 5:25 p.m. In Surabaya. Okay. I wonder if you would like to answer some more questions. If not, then because of the time, I have to stop.
I'm okay.
Oh, you're okay
then? Yeah, I'm okay. But and also you may take time, and audience may take time, if you have any questions, to email me.
Yes.
Do not hesitate to email me at this email address. I will be happy to answer.
Everybody, Prof. Paik still eager to answer some more questions. Or if you feel a bit shy actually to ask, and then you can send your questions to his email. Of course, you have to say in English, to j.paik@ucl.ac.uk. He will answer as soon as he can. Okay, is there any other questions, please? Okay, if not, because of the time, okay, I'll let you to say something to close your lecture, Professor Paik, please.
Well, again, I much appreciate your invitation for this event. Thank you very much, everybody from all over the world. I hope to see you sometime in the future on face-to-face event. Thank you very much.
Okay, once again, thank you very much, Professor Jeom-Kee Paik. Ladies and gentlemen, actually ITS has a good relation with colleague professor at UCL. Okay, for example, with your colleague, Professor Paik, Professor Giles Thomas. Okay, we are now having a Newton Fund work on the safety of seafarers and fishers during the COVID-19 era. So we would like to meet you next year, if possible, offline. Perhaps you could come to Indonesia, to ITS, or maybe some of us actually coming to UCL to study for higher degree in London. Yes, okay, once again, yes. Thank you very much, Professor Jeom-Kee Paik, for your very excellent lecture today. And thank you for everybody who are very patient to follow the lecture. Once again, if you have any questions to Professor Paik, please send email to j.paik@ucl.ac.uk. Thank you very much. And I give back this to MC, Mbak Nabila. Thank you, Mbak Nabila.
Thank you, Professor Ikap and also Professor Paik for the insightful discussion today. Ladies and gentlemen, let's give a big round of applause to our speaker and moderator by using the Zoom reaction feature. Thank you very much. Thank you, Professor Ikap, for moderating the lively discussion today. And thank you to Professor Paik for sharing your valuable knowledge with us. Furthermore, we would like to present a certificate awarding to our speaker and our moderator today. Okay, the first one, this is the certificate to Professor Jeom-Kee Paik. And next one, the certificate to Professor Iketut Arya Priya Utama. Once again, thank you to our honorable speakers and moderator for your contribution on today's World Top Scientist lecture. I believe that all the audience has got more insights about safety studies, and hopefully this will be a rewarding experience to you all. And for participants, please fill the feedback form through the link that you can find in the chat box. And lastly, before we end the session, I would like to inform you that this is not the end of the World Top Scientist lecture, as we will have another exciting lecture that will be conducted next week. The next World Top Scientist lecture will discuss about robotics, automation, and digital technologies. That will be delivered by Professor Kamal Yusef Tomi from Massachusetts Institute of Technology. And the session will be moderated by Dr. Bambang Pramujati, our Vice Rector for Research, Innovation, Partnership, and Alumni. Okay, so we will meet again next week on Wednesday, the 8th of December 2021 at 8 a.m. Indonesia time. And now that we have done today's activity, we will close this wonderful occasion. And we would like to express our sincere gratitude to our respected speakers and moderator, and also to all audience for your active participation. We really hope that today's meeting will be beneficial to you all, and we hope to see you again in the upcoming lecture next week. Thank you very much, and we wish you have a wonderful day.
Thank you all. Thank you, Prof. Ika.
Thank you, everyone.
Okay, thank you, Guru Lee. Thank you, everybody. Thank you, Nabila, of course. Yeah, very nice to deliver. Okay, sorry to leave this session.
Thank you.
See everybody next time. Bye-bye.
Thank you. See you, everyone. And allow us to end the session.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information.